zoomed in. Okay, so this is the notion I already gave to you. There's like three scenarios. The point of this is there's three main scenarios. When you're graphing two lines, we're doing what's called a system of two equations. There's going to be, think like three different ways that we're going to learn how to solve systems. One is by the picture, which involves graphing the line so we can have a picture. Another one is going to be substitution and elimination. There's like extra steps here. They talk about these steps, you can read them, they make total sense. The solution is where the graphs cross. You got two lines, and if they cross, that's the point they have in common, and that's the solution. So, but you can have some other scenarios. If you have two lines, it's possible they don't cross. There's never going to be a solution. It's never going to work out. Coinciding lines, or if you have two lines that are actually turn out to be identical, and that can happen. If you have, for example, y equals 2/3 x plus 5. What if I gave you a line that was blown up a little more? It was 3y equals 2x plus 15. How did they change? How did I get the second line? I took every item on this thing and I tripled it. This one is a multiple of 3. So they end up kind of being the same line, although they are a little different. This one is 3 times as big. Or if I did this, y equals x plus 1, and then I had 2y equals 2x plus 2. They're the same line, but they're not. Okay, so these are two examples of coinciding, and what ends up happening here is if the solution is where they cross, and you take one line and you lay the other one on top of it, where do they cross? Everywhere. Everything's a solution. You would call it infinite solutions. And then the most common example that we'll deal with is that they cross one time. If they have any tilt whatsoever, eventually they're going to cross. Either they'll cross there, or they'll cross up in the future. They'll cross at some point if there's any tilts, and they're different from one another with that tilting. Okay, so you could have no solution, many solutions, one solution. Now, if there's no solution, they say it's inconsistent. That's the terminology. If it has any kind of solution, like these two have solutions, we call it consistent. And the normal one, they say independent is one solution, dependent is infinitely many solutions. I think they're really overcomplicating it with all these terminologies, but you know, every solution it has a solution everywhere, has a solution in one place, no solution at all. Yes, sir.
So the first one's consistent independent, then the second one would be
consistent. Okay, yeah, the first one, these both have solutions, so both of these are consistent.
And then the first one would be dependent, the second one would be independent.
No. This one has infinite. So that matches that second one. The first one is independent with one solution. They probably should have had them just all in order, but I kind of borrowed this little note sheet. Okay, that's the gist of the terminology. You have it, and you can keep that for the unit. All right, let's go ahead and jump into. Oh, do you need to see that some more? I basically just kind of repeated what they were already saying. An example of coinciding would be if these lines are the same. See how this one is that one times 2? They end up being the same line, and you graph it twice, and that's when you get coinciding. All right, so the meat and potatoes of what we're doing is actually a little simpler and all that. These graphs, it's going to be a lot easier to do what I wanted to do than the first set the other day. One, we're going to have two graphs, okay? We're going to have 2 lines, per graph. 2 lines. So, I'm going to use colors to help you identify. Wake up. There's going to be no surprise if you don't know what you're doing if you're sleeping. Okay. Let's look at this first one. I'm going to call that the purple one. Let's take a moment. What is the slope of the first one? What number is in front of the X?
-1.
It's a -1, correct. That's not a fraction. When we're doing graphing of lines, we want it to be a fraction, right? Yeah, give him a gentle nudge. Alright, so we just put it over 1 and we're covered. What about the y-intercept? What's that for the first one?
1.
It's a 1. Okay. So I'm gonna go ahead and start there. Oh, also, this slope is negative. So do we go up or down?
Down.
Down and right. We'll start at 1. Down 1 over 1, down 1 over 1. Go backwards a time or 2, and we're covered. Try to use the same color. Oh, that's right there. You will want your lines to be fairly straight, so that they intersect at the right spot, that you can clearly get an answer. Alright, so let me go to this greeny color for this one. I'll call this line my green one. Jake, what's the slope? Have you already graphed the first line with me? Okay, we're gonna hit pause. I'm gonna chew you guys out off camera. Okay. Hold on. Time to bark.
2.
Okay, it's 2. Is 2 a fraction, Jamie?
It can be.
It can be, so what do we gotta do?
Put 1 under it.
Okay, I'll get her next time.
Not my fault.
What's the start point? The B value
Oh, -5.
is -5. Okay, so we just go ahead and find the B value. Make sure you know the B value is on the y-axis. It will always be there. And since it's positive, what direction do we go with our, do we do the slope? Cheyenne? Come on, it's either up or down, and it's positive. Up. Up and over.
Right.
Thank you, Cheyenne Bell. Alright, so now we're gonna go up 2, right 1. Look at that, they intersect exactly right there. Since we are graphing 2 lines, I do expect 2 lines on your paper.
Why don't you do it all the way?
I drew the arrow. And I've already satisfied what I needed. I've got the solution. Where they crossed. And they cross at 2, -1. That is the answer. It is consistent and independent. It's consistent and independent. Everybody good?
Yeah.
All right. I don't think I'm gonna force this next part really on y'all, but let's take heat for a second. What do you notice about these 2 equations?
You have to solve them yourself.
Yeah, they're not solved for y. I don't think that that was a main focus for me, but I'm gonna write it down and we'll do that together real quick. Alright, so this one, this is exactly like the assignment we had yesterday. And then I'll -5 here, we're just gonna get the y by itself. Oops. Alright. Pick a color. We'll call this one the blue one. On the blue one, let's identify our slope and our B. What's the slope, Braden? What's the slope? Someone at the table, please assist Braden.
2x.
Okay, it's always the number in front of the X. We don't say X, we'll just say 2. It's positive, but it's not a fraction. Savannah, how can I make it a fraction? Put it over 1. Alright, so what direction do we go? I don't know, which way do we go when it's positive? We'll go up 2 and right 1. But we need a place to start from. Fortunately, Blake Harris is dying to tell us. What is the y-intercept on this question?
-5.
It is -5. But there's lots of 5s on this graph. There's a 5, a 5, a 5, and a 5. Which one is the right one? Blake?
Wait, oh, me?
Yeah, why not?
How do I explain it? Bottom of, wait, how do I?
Well, you're right. It's this one here.
Yeah.
This is the y-axis.
Oh,
The,
is that what you wanted
the
to do?
thing we're looking for is the y-intercept, so it crosses the y-axis at -5, 0 -5 to be precise, but whatever. And then we'll go up 2 over 1, yeah. Can we finish this example then, Jeff? Up 2 over 1, 2 over 1, et cetera, et cetera. Try and make your line pretty good. Blue one's done. Let's go to green. I don't use green much. So Mario, what's the slope on this one? Mm-hmm. The M is the one in front of the X. So it's a what? The 2? And this one doesn't matter if you got it wrong. You take it over 1, it's positive. So what direction do we go? What's the B value?
5. No. Yeah.
Hmm?
5.
That was the other one. We're on this one. On this one, the B value is going to be.
Oh, 1. 2.
It's always the constant. The number without a letter. It's this one. Boom. So like the slope was 2 and the B was 2. M, B.
Wait.
Oh, you can't do it here. It's got to be equal, y equals.
Which one are you on?
But I was doing this one.
Oh, I thought you were doing the bottom one.
But look, even that one is not 5. You have to solve for y, and then it's -5. Okay, you have to solve for. You have to make sure y is by itself. I think today on the graphing, I'm pretty sure the worksheet I have, the y's are mostly solved. Right? I'm not trying to make it too complex right away. So, but on this one, that's why I worked it out for you. But you cannot determine. That's a good thing though to notice, because we can't say that the y-intercept is 5. You can only determine the y-intercept and the slope after the y value is by itself. That's why I had to solve this. Now we know the slope is 2, and now we know the b value is -5. Same thing over here. If you had said the slope was -2 on this one, you'd have been wrong, because you have to get y by itself first, and then it's a +2. That changes the whole thing. Okay, so let's graph this green one. It has a start value of 2. We will go up 2 over 1 and a little in reverse, and then we're going to graph our line. Take some points here, go through there. All right, got our line. Where's the answer?
Nothing.
Why not? They're parallel. Solutions to systems are where they cross or where they have a point in common. They have no points in common, so there is no solution. You got a thing?
Yeah.
Check-in slip? And we call that inconsistent, which Man, whoever come up with this terminology was a real idiot.
Doesn't sound right.
No, it's very consistent. It never touches, ever. I mean, I don't know why they picked up. I don't know. Yeah, it's on the sample. No. You got. Yep. Go quickly. All right. Here's the paper. Need for the suit that just got here. Why are you so hostile? That was very hostile. Okay, I'm gonna do one more. I want you guys to have plenty of time to consider and do these things. You know what? That's too much. I'm gonna change some of these, I think. Let me double check. I'm gonna use the graph. I'm gonna change the problems. Don't focus on that problem right now. I wanna make sure this matches. Oh, okay. Yeah, it's like I thought. They're all solved for Y already, so we're really just working on the skill of graphing the two lines, which is kind of easy. I'm gonna change this one. Oh well, maybe I shouldn't. That one's gonna be. Well, we'll leave that the same, and I'll go to that one first. Okay. I'm gonna leave that the same. All right. So look, we got. Again, you're not gonna have to solve for Y. All right, not today. We're just gonna focus on the graphing. Do these lines look the same? If you just glanced at it, no, they do not. All right, and that's kind of the dangerous. Lines can look really different, and they'll still end up being the same. If I solve for this one on minus 5x, you get y equals negative 5x minus 2. Here we'll add 10x. You get negative 2y equals 10x plus 4. But we're not done. We got to divide everything by the negative 2. And you get y equals negative 5x minus 2. Look at the two lines. Like now. What do you see?
There's negative. They're the same thing.
They're the exact same. Even though they didn't necessarily look the same, things aren't what they appear. Alright, the slope for each of them will be a negative 5. Now make it a fraction. That's a down and an over. And the b value will be negative 2. So on this y-axis, this determines where we start at negative 2. It'll go down 5 over 1. 7, yeah. And we could graph one line and then the other one, but you're just going to graph it on top of itself because they're coinciding. What was the term they used? I always forget. Consistent. And yeah, the dependent, yeah. They're called, yeah, whatever. The terms that they use in the Georgia standards are kind of wacky. If I'm being dead honest, I haven't, the math degree, I've never heard those nonsense terms in my whole life, but we got to go over it, I guess. I think it's in the standard there somewhere. But the point, the big picture item is you realize you've got the same scenario twice, and they're coinciding lines, and they intersect. So the solution, you would say infinite solutions, right? Infinite solutions, because solutions are where they intersect. And then we'll dive over here. Take a look at this next set. This one's going to be a little more normal. Although, you're going to have to steal that from somebody else. I need the space to write. Alright, so I'm going to call the first one blue. last example, so bear with me. We solve for y, you're not gonna have to do that today. And then I'll have the other one be a red line. We'll go patriotic. Did y'all hear Elon Musk finally bought Twitter?
Yeah, this is like months ago.
No, it never happened. But it just really happened. Okay, are we good on the solving and stuff? All right. So our slope Jacqueline, what's the slope for the red one? It's the m value. It's gonna be your slope. It's in front of the x.
It's -2 over 3x.
Right. Well, but don't include the x. Just say -2/3. And since it's negative, Jamie, how do we do the directions? Okay, so listen. The trick that I've shown you is that the bottom number for the first time you're graphing, always to the right. The negative just means down, positive means up. That's it. Alright. Okay, so you're just gonna determine up or down. And see what we do that for, the start point's gonna be, start point will be 5. So let's do that. We'll start at the 5. And see, the point of this is, let's get it started. So I know I'm gonna go down 2/3. So once we have that point, you should be able to pattern out the rest. So if you need to go backwards, you can. Like, what if down this would have put you off the graph? Well, if you have that point estimated, you know the next one's the opposite way, and you're good, right? So this strategy, getting that first point or so down, is gonna help you get the whole thing right. And we'll go ahead and draw our line there, and we're good to go. Let's go to blue. Slope for blue, Kyle, what you got?
The slope for blue is -10.
Huh? Negative what?
-2.
Okay, negative
I was
2.
looking at the wrong one.
Okay. And when you make it
Positive 2. I mean, a fraction.
a fraction, and then what direction are we gonna go when we graph this thing?
We're gonna go
Up or down?
down.
Why do we go down on this one, Jamie? Why are we gonna go down on this one?
Just 'cause it's negative.
Our B value is 9, it's that last number. So, we're gonna start at 9. We'll go down 2/1. Rinse and repeat, look at that. That was worked out nicely. Landed right there. We don't even have to go further backwards on this one. Actually connect the dots, guys. I get it, you got the solution, but the directions are graph. Our solution is 3, 3 here. It is consistent and independent. We all right?
Yeah.
Okay. I don't expect anybody here not to really get this thing finished. They're all solved for y already. You just have to graph 2 lines per. Y'all are pretty good at graphing. So do me a favor. Give me quality graphs. Okay?
Is it on Delta Math or paper?
No, it's gonna be paper today. All right, thank you guys.